Alright, so in this video we're going to look at what I've called interesting integrals. And by that I just mean that these don't fit under the precise category of trigonometric substitution or trig integrals or integration by parts or partial fractions. Maybe they involve some sort of combination of these techniques. Alright, so here's our first example. Integral of secant theta. I actually said that this was the integral of secant theta was the natural log of the absolute value of secant plus tangent in a previous lecture. You might have noticed, but I never explained it. Well, I'm explaining it now. So here we go. So if you make a u equals secant plus tangent substitution, then you can get this answer. All right, but I'm going to actually look at it a different way here. You can check if you make u equals secant plus tangent, then du over u is actually secant theta d theta. All right, but I'm going to go a different way here. So secant's 1 over cosine, and that's cosine over cosine squared. And cosine squared is 1 minus sine squared. Aha! Well, then I can make a u equals sine theta substitution, and du will be cosine theta d theta. And lo and behold, I have a rational function in u, right? And so this rational function in u allows the partial fractions decomposition in my thought bubble over here, namely that this is equal to 1/2 integral of 1 over u minus 1 minus 1 over u plus 1, like so. And then I integrate and convert back off the edge of the world here. Let me scroll up a bit. And so we get 1/2 log sine theta minus 1 minus 1/2 log sine theta plus 1 plus a constant. There you go. That's your integral of secant theta. Now that, I don't usually write that down because I prefer to write this. It's, like less writing. But in fact, this and star are the same answer, but they might not be obvious to you at the start, is it? But you can actually show that those are the same. All right. I'm not going to do that here. All right, next example. Log of x squared minus 3x plus 2 dx. So again, the rule of Liate still applies. We've got log, so we make that our u. All right, when we do that, our dv is dx, so v is x. So this is uv minus the integral of v du. But v du in this case is something that it requires a little bit of thinking. Actually, we've got quadratic over quadratic, which means we first need to, let's see what, work on star alone. So first order of business is to simplify that to 2 plus 3x minus 4 over x squared minus 3x plus 2. This is the long division which justifies that. All right. So this is equal to that. Now that's a proper rational function, so I can try to use partial fractions to decompose it possibly. Does the denominator factor? Well, yes it does. That's x minus 1 times x minus 2, which gives us this partial fractions decomposition when we work through the details in the thought bubble to the side. This equals that, multiply by the denominator, plug in 1, plug in 2, out pops a equals 1, b equals 2. Huh, funny. And so then we get back to here. All right, integral of 2 is 2x, that's that integrates to that. So at this point, all I've done was just to integrate. I've done the integral of star up here, right? Now we put it all together, and there you have it. This integral of the log is x cubed minus 3x squared minus the log of x, the absolute value of x minus 1, minus twice the log of the absolute value of x minus 2 plus a constant. Maybe this is a good time to stop and say something. In Calculus 1, it's possible that a very talented student at memorization might be able to memorize their way through the course, right? It's conceivable. You could memorize answers to everything without understanding. It starts to become very implausible in Calculus 2 to memorize everything. You really need to understand the techniques and not try to memorize examples. Memorizing examples is a foolish way to study this course. You must try to understand the techniques. Anyway, common sense for you. Here's another one. And by the way, these are endless. I'm just giving you a few sample ones. The larger point I'm making here is I'm inviting you to combine techniques to solve interesting problems. There's more in your homework to play with, all right? So integral of the square root of 3 plus x over 3 minus x. Aha. Well, let's see here. So what I did was I multiplied by 3 minus x quantity squared, like so, which is a good move because then at least I only have one square root. Having one square root's a good deal because then I can do trig substitution. And so I do that. X equals to 3 sine theta. 9 minus x squared reduces to 9 cosine squared. That removes the square root. The dx produces a cosine theta, so I get 1 3 cosine theta from the square root. I get a 3 cosine theta d theta from the dx. They combine to give me 9 cosine squared theta there. Downstairs we've got 3 minus 3 sine theta. And then I decided I would change my cosine squared to 1 minus sine squared. And so doing that allows me to factor this into 1 plus sine, 1 minus sine. Those cancel. And yay, I can integrate that. 3 theta plus 3 cosine theta. Then I go back to my trig substitution, draw my triangle to illustrate the substitution, and so that gives me an inverse sine of x over 3 plus 3 times the adjacent over the hypotenuse, which in this case is square root 9x minus square root 9 minus x squared over 3, of course, plus a constant. And there you have it. The integral of the square root of 3 plus x over 3 minus x is perhaps surprisingly the inverse sine of x over 3 plus the square root function. Kind of neat. Here's another one. Popular problem. Integral of the cosine of the square root of x. So this time we make a kind of surprising substitution. We make w equals the square root of x. And so doing that, this makes the dx turn into 2w dw. And then we're like, aha, this is integration by parts. So we can make a u equals to 2w and a dv equals to cosine w dw substitution, which gives me uv is this minus integral of v du is that. I can integrate, and then I go back to my root, my square root, unsubstitute the w substitution, and there's the answer. If you try to do this directly by other means, so the larger story here is to solve integrals, you need to be creative, and that kind of creativity, it's not like writing a creative story in middle school or something where you can just make up any old thing and your teacher's going to be like, good job, Johnny, or good job, Jane, you've written words in cogent sentences and made up some nonsense. No, I mean, the creativity here is a guided creativity that is born of experience and practice and educated guessing. All right, so that's part of your job. Doing homework is becoming educated so you can make educated guessing a reality for yourself. It's not easy, but you can do it. I think you can do it. I can't say for sure that you can do it. I don't buy into that. I'm sorry. It's just I can't do it. Anyway, thanks. There's 5 examples, so I hope that helps.